Hi, welcome to Pre-AP Physics 3.3 Newton's Laws. First law is known as the law of inertia. Second law is F equals ma. And third law is action-reaction. So let's talk about the first law. You're going to be getting a packet handout that goes along with this video. What I want you to do is watch the first section of the video and then pause it, and then do the first section of the assignment. Watch the second part, do the second part, third part, and do the third part, okay? All right, so the first law, Newton's first law, is known as the law of inertia. It says that an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. That means that an object in motion or rest will stay in motion or rest unless acted on by a net force. Inertia is the tendency of an object to resist changes in its velocity, whether it's in motion or motionless. Those pumpkins will sit there forever unless acted on by an unbalanced or net force. Once airborne, the golf ball, unless acted on by a net force, it would never stop. It would keep going forever. Gravity is the net force that pulls it down. Also, unless acted on by an unbalanced or net force, the golf ball would sit on the tee forever, again, barring any unusual circumstances like earthquakes and so forth. So why then do we observe everyday objects in motion slowing down and becoming motionless, seemingly without any outside force? It's the force we can't see, friction. Objects on Earth, unlike the frictionless space the moon travels through, are always under the influence of friction. And there are four main types of friction. Three are sliding friction, like ice skating, rolling friction, like bowling, and fluid friction, which could be air or liquid. So when you slide a book across the table and watch it slide to a resting position, the book comes to rest because of the presence of a force. That force is friction, which brings the book to a rest position. So in the absence of the force of friction, the book would continue to move forever with the same speed and direction, or at least until it hit the end of the table. Don't let this be you. Always wear your seatbelt. Because of inertia, objects, including you, resist changes in their motion. When the car is going 80 kilometers per hour, is stopped by the brick wall, your body keeps moving at 80 kilometers per hour, unless you have your seatbelt on. An object in motion tends to stay in motion. All right, right now what I want you to do is pause this video and go and do pages 1 and 2 of the packet that I gave you. Hi, welcome back. Now let's do and look at Newton's third law. Forces come in pairs, okay? So Newton's third law says for every action force, there's an equal and opposite reaction force. And the force is important. This is not just a reaction when someone scares you. This is actually an action force and a reaction force. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. That is an action-reaction pair. There are two forces resulting from this interaction, a force on the chair and a force on your body. These two forces are called action and reaction forces. Flying gracefully through the air, birds depend on Newton's third law of motion. As the birds push down on the air with their wings, the air pushes their wings up and gives them lift. This is why birds can fly. The size of the force on the air equals the size of the force on the bird. The direction of the force on the air, downwards, is opposite the direction of the force on the bird, upwards. Action-reaction force pairs make it possible for birds to fly. Another example of Newton's third law is the baseball forces the bat to the left, an action, and the bat forces the ball to the right, the reaction. Consider the motion of a car on the way to school. A car is equipped with wheels that spin backwards. As the wheels spin backwards, they grip the road and push the road backwards, pushing them forward. Also, we have rockets. The reaction of a rocket is an application of the third law of motion. Various fuels are burned in the engine, producing hot gases. The hot gases push against the inside tube of the rocket and escape out the bottom of the tube. As the gases move downward, the rocket moves in the opposite direction, allowing liftoff. Now I want you to pause the video and go do the back 2 pages, the last 2 pages, for Newton's third law. Hi, welcome back to Newton's second law, F equals ma. Newton's second law really says an object will accelerate in the direction force is applied and force equals mass times acceleration, F equals ma. The ball will roll the direction you tell it to. So when mass is in kilograms and acceleration is in meters per second, the unit of force is in newtons. And we've done problems like this for 3.2. 1 newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second. So Newton's second law proves that different masses accelerate to the earth at the same rate but with different forces. We know that objects with different masses accelerate to the ground at the same rate. However, because of Newton's second law, we know that they don't hit the ground with the same force. The force of the first boulder or rock that is falling, that is 10 kilograms, is 98 newtons, whereas the small pebble is 9.8 newtons. All right, finally go and do the middle 4 pages of the packet for Newton's second law. Thanks for watching.